Good morning, everyone. I'm just going to give it one more minute for people to join. Alrighty, so welcome everyone. My name is Ina Paricio. I'm a marketing manager here at EDB. I will be your host today for our webinar, Deploying and Optimizing Clusters with Cloud Native PostgreSQL. I'm joined by Adam Wright. He's the Senior Product Manager here at EDB. Before I turn it over to him, I'm gonna go over a few housekeeping items. So number one, this presentation is being recorded. We'll be sharing the recording and the slides after the webinar. And then two, the lines are muted. So if you have any questions, just drop it in the question panel and we'll get to those right at the end of the presentation. With that said, I will hand it over to Adam to kick us off.
All right, thank you, Ina. Hello, everyone. Today we're going to talk about deploying and optimizing clusters with Cloud Native Postgres. Like Ina mentioned, I'm a product manager here at Enterprise DB. I am responsible for containers and Kubernetes, which make up our Cloud Native PostgreSQL product offering, and I'm also responsible for backups. And before becoming a product manager here at EDB, I was a longtime consultant who worked in the field, worked with a lot of customers who were adopting PostgreSQL. All right, let's get started. On the agenda, so we're going to do a quick recap, talk about Cloud Native PostgreSQL just to make sure that you have some foundation knowledge. We'll move quickly through that, and then we'll talk about deploying PostgreSQL on Kubernetes with Cloud Native Postgres, connecting to PostgreSQL, some of the different connection patterns to hook your application into PostgreSQL running on Kubernetes. We'll talk about insights, that includes metrics, monitoring, and then we'll get into backups, the important things that you need to do from an operational perspective after you've deployed Postgres. And we'll recap the CNP capabilities and then the next steps if you want to get started or if there are further advanced things you need to do with CNP. All right, so a quick recap. So EDB's qualifications for running Postgres on Kubernetes. So EDB is the largest dedicated PostgreSQL company. And when we started working on our second generation containers offering, we went all in with Kubernetes. So we are the first dedicated PostgreSQL company to become a Kubernetes certified service provider. We are a silver member of the CNCF and Linux Foundation. Just a couple of months ago at KubeCon Europe, the developers gave 10 presentations in 4 days. Our operators are certified through Red Hat for running on OpenShift, so OpenShift certified operators. And we are a platinum founding sponsor of the Data on Kubernetes community. The Data on Kubernetes community is advocating, doing evangelism for running stateful workloads on Kubernetes. So you can go join the Slack channel. They have a YouTube channel. There's a lot of good information that is vendor agnostic for running databases on Kubernetes. So first, when I talk about Cloud Native Postgres, it's important to understand Kubernetes operator. So I mentioned when EDB was looking at designing and developing the second generation containers offering that we went all in on Kubernetes. And the reason we went all in on Kubernetes is because of the operator framework. So if you think about the transition to stateful workloads in Kubernetes, we have web servers and, you deploy a web server in a pod, a container on Kubernetes. If that web server goes down, what do? Well, you just restart the web server. PostgreSQL is more complex, right? There's if you're running in an HA mode, there's a primary, there is a standby. You can't just restart pods at any time. You can't just kill pods at any time because the host died and then reschedule them on another worker node. You have things like switchovers, failover, failback that need to be accounted for. So PostgreSQL itself, is a complex application. So what the operator allowed us to do is EDB being Postgres experts is take all of that application knowledge that we have, our support group, our consulting groups, everything around Postgres operations, and put that into an operator. So things like deployment and configurations, failover detection, failover, how do you patch, how do you do switchovers, backup and recovery, all of that we've been able to code into the operator. So a lot of the operations work that you were doing previously, where you had run books, hey, we're going to do patching, let's go to the run book and start with the fourth node, go to the third node. All of that stuff is handled by the operator, so you can focus on more high value, company specific work. And we're doing this by relying on native components and capabilities. So things like self-healing, Kubernetes has reconcile loops that we're able to take advantage of. There's a high availability components of Kubernetes. So we're able to design from scratch in a very Kubernetes native way. So we didn't take, like a VM architecture and try to shove it into Kubernetes. We designed this from the ground up to be Kubernetes native, and that being declarative and fully automated. And we'll see some slides and also do a demo where you can sort of really understand how a declarative database behaves. So there's the operator, and then there's the operands. The operands being the application PostgreSQL. If you need to get the images, they're hosted on key.io. We rebuild those images. So every night we check, is there an update to the base image? So if there's a patch for GCC, there's a Red Hat UBI image update, anything like that, then we're going to rebuild the image. And then we also check for Postgres minor updates as well. So every night we do a check. One of those two things matches, or both of those things matches, then we build a new image. And we do have multi-architecture support. So we now we've supported x86 from the beginning, but we also support Linux on Power and then Z-Linux as well. So if you're running on those platforms, you're running OpenShift on IBM Power processors, then you can deploy Cloud Native Postgres. And so one quick point here. So the operator can orchestrate both PostgreSQL, 100% community edition, and you can find the Docker files for that on Enterprise DB's GitHub page. That's fully open source. And then there's EDB Postgres Advanced Server, which is EDB's proprietary database with Oracle compatibility. Same operator. The only difference when you do the deployment is the image name. So which are you going to pull, the PostgreSQL image, or are you going to pull the Postgres Advanced image? The same operator. All right, see, the images are based on UBI, and we support versions 10 through 13 PostgreSQL. So in the last week, we can remove this in preview line here. So we support 10, 13, and 14. And then with EPAS 10 through 13, and then 14 will be out in December. And as soon as that's released, we'll automatically have support. We've already got release candidates that you could test with today if you wanted to give 14 a spin. The only other, these are very lightweight images. The only thing that we add to these images is Barman Cloud for backups. As you'll see later, backups are tightly coupled with the deployment. And then you could install PG Audit if you want to. You can do that in a declarative way. And then we have separate images for PostGIS. The reason we keep those as separate images is just because of the size. So if you don't need PostGIS, you can just roll with a lighter image. If you do need PostGIS, then you can pull an image that has all those dependencies on there. And you're not locked in, right? So you can update your deployment YAML and then add PostGIS later if you decide, if you have a future business requirement that requires, a geometry to geography data type. All right, so let's get into deploying Postgres and Kubernetes. And each section here, just do a short little demo to highlight the capabilities. All right, so we went with convention over configuration. So this is the declarative model. These lines here are all that you would need to deploy Cloud Native to deploy a Postgres cluster on Cloud Native Postgres. This is all that's needed, right? So there's a lot of opinions that EDB has that we've baked in already, but you can go like to the full example, you can go to the CRD, the documentation that we have, and see a lot of the more advanced options, but this will get you a PostgreSQL cluster named MyAppDB that has a primary and 2 standbys. And this is the image that's going to be pulled. So this is PostgreSQL 13.4. The -3 here means this is the 3rd UBI image. So there's been three updates to the base image to patch Red Hat UBI. And then the storage size here. So this is going to get you a 10 gigabyte PG data directory that's attached to the pod. All right, so this is it. Just this here, kubectl apply, and apply this YAML file, and then that change is going to post to the Kubernetes API server, and you're going to have a primary with 2 standbys that have been deployed with EDB best practices already. So this is a declarative deployment, kubectl apply, the operator, and you could just deploy that from the web URL that we have in the documentation under the installation section, and then kubectl apply, and this will deploy your application cluster, the application being Postgres. And when we talk about declarative, so what we're talking about is not a set of instructions, step 1, install PostgreSQL, configure it for high availability, take a PG-based backup. What we're saying is instances : 3. That's our desired state. So we post that state to the Kubernetes API server. And so if we're doing a new deployment, our desired state is instances : 3. So we're going to bring up a primary, read write, a standby, and then a 3rd standby. And then if a 3rd standby drops off, something happens, the pod dies, something happens to the host, then we're going to schedule a new standby. And this is where the Postgres expertise comes in, that we know what that standby is going to be. And then the primary drops off, and then we're going to perform a switch over. So that 2nd standby, the most up-to-date standby, is going to be promoted. And then our desired state is still 3, so we're going to bring in another replica. We can scale up as well, so we can add a 4th instance to our cluster, and then the operator is going to add another streaming replica to the cluster. And then we could also go back, scale down. So if you have an elastic workload and you want to, it's very read heavy, you want to do a lot of read services, point your applications to the read service. And then once that rush is over, then you could just drop instances : 2, and then we're going to get rid of 2 of those pods. All right, so I'm just going to do a demo here. You can see my screen well. So I already have the operator deployed. It was a single command. And then let's just go ahead and take a look at that YAML file, my custom resource file. This is a little bit longer than the example that we had, but you can see where the customizations are. So our image name, PostgreSQL, so this is 13.3. There is a 13.4 patch that's out already. We're just going to do a 1 gigabyte PG data directory. This is all just running on my local laptop. PostgreSQL parameters, so this is all declarative again. Like, so, if you have a large table, you're doing lots of sorts, then you might want to bump up the work mem size, and you can do this declaratively. So this is going to get you the global work mem parameter 64 megabytes. And then we have a bootstrap framework with Cloud Native Postgres. So we're going to initialize a new database. The initdb command, if you're familiar with that with Postgres, we're going to pass these parameters to it. And then the operator is going to create a new database called Shogun World. The owner is going to be Maeve, and the secret here is where my password is stored. So we're going to create the owner Maeve, create a database username Maeve, set the password to the value in the secret. And I've already got that secret created. And you can see that secret here. All right, so I'm just going to go ahead. All right, so my cluster is created. Now we integrate with the Kubernetes API server, so I can just do something like kubectl get cluster, do my output YAML so I get a little bit more information. And you can get all of the cluster information here. So like these PostgreSQL parameters, these are what the operator is managing. So you can see the wall keep size, work mem size that we had set in our cluster resource. And then these are the parameters that the operator is managing by default. So these has to be defined in your deployment YAML. And then you can see the image name, and you get a lot more information here. We also have a plugin. So this is not a separate tool. This is a plugin for the kubectl command that you are already familiar with if you're using Kubernetes. And we give this just, I'm going to clear this here just to make it a little bit more readable. And this just gives you some of the same information, but formatted in a more visually appealing way. So we can see here, instances is 1, everything is healthy, my image name, and then you get the streaming replication information here. So we only have 1 instance here. So that's my primary. And then we're not replicating to any other pods at the moment. So let's go ahead and we'll just go ahead and show earlier. So I'm going to do exec pgha Dolores-1. That is my pod. The container is Postgres. Do psql-c. We'll list the databases and we'll describe users. So you can see here with my deployment, the operator automatically created this database Shogun world with the owner Maeve, and the Maeve user was created as well. And then if I go up here, I'm just going to backspace here. We'll do select version. And we're running PostgreSQL 13.3. Now, if I go to key.io, I'm just going to bring up my web browser and do a visual search. PostgreSQL, container registry. I already know that there's a 13.4. So there's this 13.43 image here. So we're running 13.3 now. So we want to upgrade Postgres. So this is actually going to do a minor update of Postgres, and we're also going to do a patch to the underlying container itself, which has some UBI updates. So I just need, instead of changing my configuration on disk, I'm just going to go ahead and change this live 13.4-3 pgha Dolores.yaml kubectl apply-f. All right, so that configuration is there. Posted my change to the API server, CNP status pgha Dolores. All right, and so we get some information here. So we can see we're upgrading the cluster. The primary instance needs to be restarted. Reason, the instance is using an old image. So we detected this change. And that change has happened already. So you can see the new PostgreSQL image. And then if I run a psql command, we can see that we're now running PostgreSQL 13.4. And we also have declared that we want instances 3, but if we want to scale up and add high availability, maybe we're taking this cluster that's deployed, from testing to production, we can go ahead and change the number of instances. We'll do something very similar. Instances, all right, make sure I don't have any typos there. E, and then I also need to make sure that I have the right version change, because if not, that would have just rolled back. 13.4-3, all right. All right, make sure I get everything right. So we're going to change instances 1 to instances 2, and then we're going to keep the same image that we currently have. All right, so that's been configured. Now let's go ahead and see the status. pgha Dolores is the name of our cluster. And now you can see instances 2, and now we have a streaming replica. So this is being replicated. You can see the system ID, you can see the logical sequence number. So where in the wall is that cluster at? All right, and so I'm going to delete this cluster now, and we'll start over fresh after the next section. All right, so, all right, now jump back into the slides. All right, so for connecting to Postgres, right, there are two different ways this is going to happen. So you would have an application that's inside Kubernetes, and this is going to be the most common pattern. So your application has its own service and connects to the Postgres database. So this is all within Kubernetes. Then you have applications that are outside Kubernetes. That these could be a couple of different situations. Maybe you just have some application that's not been lifted and shifted to Kubernetes, or maybe you have like an analyst that needs to connect their desktop application to Kubernetes. Just because it's in Kubernetes doesn't mean all the same work patterns have gone away. So you would expose their TCP port 5432 to the outside world, and then Kubernetes DNS that comes along with that. So you could connect your application from the outside, whether it be a proper application like a Java application, a web application, or a desktop application that your analysts use. All right, so here's a graphic of that first one here. So your application typically has like a replica set. So these are 3 pods that can be restarted at any time. And then they're going to connect to this service that CNP creates. I'll show you just in a second, the importance of this actually connecting to the service rather than connecting to the pod IP address. So the stateless application can do rolling upgrades. These can change quite a bit, but they're always going to have a static connection to this Kubernetes service that we create. And the reason that's important is because you're running Kubernetes long enough, you have a large Kubernetes cluster, there's going to be a lot of IP churns. So when we create these Kubernetes service objects, these give you a reliable DNS endpoint for your application. So automatically, the operator is going to create these services. So we have like a read-write service, we have a read service, and then the operator uses read-only service. And so within your application, if you're doing a write, you create a connection class for this write service, and then always point to that write service because it's always going to go to the primary. So if something happens to this primary pod, the standby gets promoted, then this service is going to start pointing to the newly promoted primary. So there's nothing that you need to do to make that change in your application. And then the same for read. So if you have parts of your application that are read-only, then you could, utilize the other pods in the cluster. So just taking some of that work off of the primary, actually getting to use some of the compute resources on the other nodes. And then you could point to that read service, create a connection class for that read service, and then round robin the connections between these services. All right, so I'll go ahead and show a couple of examples here. Pull up my terminal window. Here, so I talked about the analyst applications here. So I just go ahead, just do. Right, so this is very similar to the cluster definition that I had before, but in this case, we have a PostGIS image. So this is Debian-based, PostGIS, and we have all of the similar settings here from earlier. So I'm going to go ahead and apply this cluster. And then standard kubectl command gets services. These are just standard Kubernetes service objects, similar to what we had before on the slide. And then I'm just going to forward the port here to my local system. So KC port forward service PG HA Dolores RW and port 5432 that Postgres is running on. Okay. And now I could connect my local system here. Just like we're running local here. So I'm just going to use psql And this is the secret that I set earlier. And since we're using a TCP/IP connection, one thing that the operator does automatically is create TLS certificates. So you have the option to bring your own certificates. If you don't, the Cloud Native Postgres operator is going to deploy a certificate authority, generate TLS certificates, and by default, drivers are going to default to try SSL connections, and that's what we did here. You could enforce if you wanted to through your configuration. If you want to enforce that, you can't even bypass TLS, you always have to use TLS, then you have that option in your deployment. So we're using TLS v13 here. All right, so I'm just going to exec in because I'm going to run a local application, PGHA Dolores, and I'm going to go directly to this pod. And we're going to run psql. Oh, sorry, I didn't put my container in there. So then if I connect to Shogun World, now connected to the Shogun World as user Postgres, and I'm going to run pgbench. I'm going to initialize pgbench, fill factor 90, scale, that's how large my database is going to be, and then connect to Shogun World. All right, this is a brand new cluster, so I don't already have pgbench. And now we're going to run a pgbench job. Connections to, time 30 seconds. Print progress every 10 seconds. It's just going to give us a little bit of traffic. That way later on when we go and look at our logs, then we can actually see some of the application traffic that's hit our Postgres cluster. And this is just running on my local MacBook here. So Kubernetes and Docker. So 1500 TPS for a local, untuned system here. All right, so we see our pgbench runs. So we could connect, from inside Kubernetes, we can connect from outside Kubernetes. And so we have Shogun World here. Let's just go ahead, select name from PG available extensions. We can see all the extensions that are available to us. And here is PostGIS. So go ahead and create extension PostGIS. All right, so DX, and we have PostGIS installed. Now I have shape to PGSQL already installed on my local system, so I'm just going to go ahead and run that now. So our spatial reference system is 4326. This is going to match spatial reference system being used if you want to visualize things using OpenStreetMaps in pgadmin. And I already put in a shape file that I downloaded. So this is the Census Bureau US states for 2020. And we have that local connection exposed. 3.2, we'll do this as user Postgres. And we'll do database Shogun World. What I don't have is the super user password. So that super user password, if we don't define it in our custom resource, then we need to get it from the secret. All right. All right, so we just loaded a shape file into our Postgres deployment. And I'm just going to go ahead and open up pgadmin just to kind of just show a little bit, if you are an analyst, this might not be pgadmin. This could be like a GIS desktop application. Maybe you're doing some cartography work, using some other analytics system. Sorry, this opened up on my other screen. Servers, Dolores. And this is that same super user password. So you can see my Shogun World database, the tables I had PG Bench. You can see some of the traffic since we opened. And then I also have the Census Bureau 2020 US states. Go ahead and look at the data. This should open up shortly. And since I have a geometry column here, it's quite large. This is our geometry column. Then I could get some visualization here of our PostGIS data. Sorry, I just undocked that accidentally. This is all running on my local system, so it's going to take a little bit. But you can see that we can now get a visual of our data. If we want to filter this data further, we could do that. If you have your own custom data and then you want to start running your own spatial queries, then you could do that as well. I'm just going to go ahead and close this out now. It's taking up quite a bit of resources on my laptop. All right, I'm just going to go ahead and delete our PostGIS deployment. And go back to the slides here. All right, insights. So if you're a Postgres DBA and you're moving to Kubernetes, how are things different? This is an area that's quite a bit different after you've done deployment. So there's the metrics aspect of it and there's the log aspects of it. So we have a native Prometheus exporter that comes with each PostgreSQL instance, also comes from the operator. So these are going to get you metrics about the database. We'll get into more detail in just a minute. And then there's also the logging aspect of it. So this is quite a bit different if you're managing Postgres, say in a VM environment. Since we're doing Kubernetes, we want everything to go out into JSON format because typically these messages in Kubernetes are going to be picked up by another logging system. So we redirect everything to standard out in a JSON format. So each PostgreSQL instance automatically has a exporter, and that's exposed via HTTP on port 9187. And you can add your own queries. You can also download the sample queries that we have in the documentation. We also have a project within EDB where we're extending the amount of metrics that we expose, and those will all be available for you to pull down. So these are user-defined queries that are stored in a config map, and then those go along with your custom resource deployment. And then here's some details about how the monitoring queries are executed as Postgres with the PG monitoring role. And then we have the application name set to CNP metrics exporter. So here's an example of this. So we're getting some replication information. This is stored as a config map and then referenced in your deployment YAML. And then we just have our standard query here. So select case when not PG is in recovery. And then we can get replication lag behind primary and seconds. So with this in your custom resource, then you would automatically see this on your metrics endpoint. So we just add it to the cluster spec here, example monitoring key custom queries. Now, the next phase that we're working here on EDB is to have some dashboards that customers can pull down themselves. So you can build custom dashboards, you can have like this whole view, your application, your database, whatever makes up an entire system. So you could pull that into your existing monitoring system. If you want just a deployment focused dashboards, then these Grafana dashboards are a project that we're working on EDB to provide to customers. This is the MVP that we have, but this is pretty slick in that you get a view of the cluster view in total, and then below you would get all the critical information that you need in operations for managing Postgres. All right, so logging is quite a bit different. You're not SSHing onto the machine, going to the PG data log directory. You're actually getting the information outputted in the standard way that Kubernetes applications export, which is JSON formatted to integrate with other logging systems. And this extends beyond just the standard Postgres. So PG audit is something we deploy with Cloud Native Postgres. You can turn that on declaratively in your custom resource. And then that is in the standard logging collector. And then EDB audit typically goes to CSV, and we convert that to JSON. So everything is being automatically formatted as JSON and sent to standard out. So we implemented the custom log reader here. So CSV files outputted, custom reader, and then out to JSON to integrate with your other logging systems. So we'll just take a PG audit example here. One of the nice things here is logger PG audit. So you could also send in different directions, right? So if you're working with a sensitive system, something that might have regulatory requirements, might be dealing with financial data, then you could have PG audit go to your SIEM, it's a logging system that's managed by the security team. And then you could have other logging information that's Postgres specific for DBAs go into a DBA logging system. So you can have some separation just based on this logger type, or you could just have it all go to the same place. But you have those options. By the way, this has been set up by CNP. All right, and then the PG audit extension we'll see. So this is pretty slick. So in PostgreSQL, we are doing declarative PostgreSQL parameters. So if you want to set shared buffers, you set that in your custom resources. With PG audit, the way this has been implemented is the operator will detect, hey, there's a PG audit setting in the parameters, and automatically install the extension for you. So if by putting PG audit here in the parameters section, you're automatically declaring that we want this cluster to be audited. All right, so I'm going to go ahead and pull up terminal. We'll take a look. All right, so let's go to that metrics endpoint here. So apply. Let's just go ahead and do audit actually before we do that. Audit Dolores. So very similar to the slide here. We have some PG audit information here. I haven't said anything else about PG audit in my custom resource. So we're going to do kubectl apply. And let's go ahead and exec into our pod or the primary. Where's des1? Go directly to our Postgres container. All right, and let's just create a new table. Create table tbfoo as select one as a. All right, so now we have our tbfoo table, and then we'll delete some data from tbfoo. Delete. We don't want to delete tbfoo. Delete from tbfoo, where a equal 1. And now we'll just go ahead and drop table tbfoo. So we're just generating a DML statement, generating a DDL statement here. All right, and then to show you what I was talking about earlier with PG audit. So I'm connected to the template database. So when you create a new database in Postgres, we're essentially copying that template database, and then you add all your customizations later. So within my template1 database, since I defined it from the beginning of my custom resource, we've added PG audit. You created a new database, and PG audit came along with that new database. So your database that was created during the init process has been audited from the very beginning. So everything you would have done with this database would have been audited. All right, so let's go ahead and quit. We're just going to do the standard Kubernetes logs command for kubectl. Go pgha Dolores -1. It's my pod. We'll get a pretty formatting with JQ. All right, so what do we get? This last record here we can see already. So we have drop table. and the logger type is PG audit. And then we can also see, so this is part of that same connection here. We're running a delete statement, so our command tag is delete. The connection is from local. In a production system, especially one that's being audited, you're probably not going to be allowing someone to exec into your pod, but this is for demonstration purposes, so this is local. You would most likely have an IP address associated with this, but if something did happen where you needed to have exec privileges or you did have exec on the container, then you would be able to see that, hey, this was a local connection that was made. It's the Postgres user. And someone with exec privileges would have had to have been the one to execute this. Now create table as statement, and then we can go up here. We can see some custom monitoring queries. You can see the Kubernetes event messages are here as well. So you could have, different messages going to different places or all to one location. And then we could see, since we did enable PG audit from the very beginning, we can start to see the processes that actually happen as part of the init process. So alter role Postgres with password redacted. So this would have been the password that was automatically generated with the cluster since we didn't have it defined in our custom resource. All right. Let's go ahead and take a look at the metrics endpoint. So Mesa Hub, we're going to do an exec here. PGHA Dolores 1. Curl the web server. Spell curl right. 0.19187. And then we can see some of our standard operator Go messages coming out. And then we see other things like PG stat databases. These are the queries that were part of that config map. The config map that I uploaded is the sample configuration that you would find in the Cloud Native Postgres documentation. So then the next step is, if you want to get a visual of this, is this Prometheus exporter and then getting Grafana dashboards to consume the metrics. All right, go on to our next section here. And backups. So you deploy Postgres, you need to, how you're going to back up the system, how you're going to restore the system. Backups are part of the custom resource. They're tightly coupled with the deployment. So these are continuous physical backups. They are scheduled in on demand. If you go to the documentation, you'll see we also have the option that as soon as a cluster is initialized, that we take a full backup. What that allows you to do is you could rewind the database time, from the very beginning when the cluster was initialized. But you don't have to do it that way. You create a on-demand resource and execute that, so that if you have another job scheduler, an enterprise job scheduler, and you want to take backups that way, you can do that. Or you can put in your standard cron syntax to schedule backups to run, as jobs every so often. So maybe once a day you take a full backup, and then we're going to use the wall archiving that's set up automatically by the operator to be able to restore to a point in time after that full backup was taken. So we use Barman Cloud for our backups, and these are kind of aimed at object store environments. If you have other data, other targets for storage, MinIO gives pretty broad coverage, extremely popular these days. But today, natively, we support Amazon S3, we support Azure Blob Storage, we are working on IBM Cloud Object Storage, and then if that's not covered, MinIO Gateway will probably get your wall files and backups to where you need to go. And then, of course, this list will be expanded based on customer feedback. So these are standard commands that are run: Barman Cloud Backup, Barman Cloud Wall Archive. Taking backups, you need to be able to recover. So we can create a new cluster from a backup. So we have the Bootstrap framework from our earlier deployments. We had initdb here. But here we have recovery, so we're pointing to our backup here. So we're going to bootstrap a new cluster from a full backup. This definition here, that this will restore, this will create a new cluster based off this backup, that this is all that you need. If you needed to, you wanted to roll forward past the last full backup, but not to the latest, then you would put in the configuration with a timestamp or a transaction ID to some point in time before the latest. But by default, we're going to roll forward to the very latest transaction that's in the WAL files. All right, so let's go ahead and do show an example of taking backups. So I'm going to get, not sure if I deleted my old cluster. Okay, so I'm going to go ahead and delete. That would have been our audit deployment. All right, just take a look at the backups real quick. Bat pp, do backup.yaml. All right, so I have S3 URL here. So we have this backup section in our deployment, and we have this S3 URL, our endpoint URL. Our creds are stored as secrets in Kubernetes, and then we have some information. So compression gzip for the WAL files, compression gzip for the data files, and issue an immediate checkpoint that could be true or false. We're taking when we initialize that full backup. So everything else here is standard. And I'm just going to go ahead and apply our backup configuration. All right, CNP status. All right, so our cluster is healthy. We have instance 1. Let's go ahead and clear here. And then I have an on-demand backup configuration. So I'm going to do KC, apply, on-demand. All right, so the backup was created here. Now let's go ahead and we'll generate some data here. So we've taken a full backup. There's not really anything in the cluster at the moment. So J Dolores, container, Postgres. We'll go ahead and just run psql. We'll chain a few commands here. So we'll create table, tb foo, a small integer, do select pg switch wall to activate the wall archive command. We'll sleep for a few seconds, pg sleep. Five, sure I got everything right so far. Create table, tb foo, column A, small ints, pg switch wall, pg sleep, and we're going to execute our final command here, select star from pg stat archiver. Everything looks right. Oh, sorry. That's the name of our deployment. Let's get the name of our pod here. All right, so create table, pg switch wall. These are messages coming back from psql. And then archive count 1, and that archive did not fail. And then I have a command here on my local system to just go ahead and list all the contents of our S3 bucket. And then we have our WAL files here. All right, so let's go ahead and describe the backup. All right, so this backup is still running here. This is going to go from my local system up to S3 across the country. So it's taking a little bit. It's backup started. Backup completed. Now, if I go back and look at my S3 directory, and there's our full backup. And then here are the WAL files. All right, so let's go ahead, running short on time. I'll just go ahead and do a quick restore. Okay, so we're restoring a new cluster. And the name of our cluster is going to be restore-Dolores. And primary server is initializing. And we're in a healthy state. So we added some data after we took the last full backup. So let's just go ahead and make sure that that data is there. So we created that TB food table after we started the full backup. Although there was some timing issue because that came a little bit after, I executed that too quick. But let's just go ahead and take a look. Container, Postgres, psql. Space here. So we have our new cluster, Restore Dolores, and this table that obviously we haven't done anything. This was a new deployment, and this was part of our backup. So even all the data that was part of a full backup and all the data that comes after the full backup, because the operator automatically sets wall archiving up, that's not something you have to do separately. We would have gotten all the data. We didn't specify a point in time, so we would have recovered to the very last transaction. All right, so let's go ahead and wrap up the slides here. All right, just a quick recap on the capabilities. Cloud Native Postgres, you do it declaratively, and we're using the same operator, the same deployment files, so you can deploy anywhere. This can be in your private cloud, in your data center. This could be in the public cloud. This could be hybrid cloud. Same operations, the same operations path. You don't need to do something separate because you're in this environment. It's the same HA management, same backup management. Automate DBA tasks, so you can throw a lot of the run books away that you might have today in the VM and bare metal world. And you also get to avoid lock-in. So you have your platform of choice. This can be your private Kubernetes. This could be a public managed Kubernetes. It's your platform of choice. You can choose between PostgreSQL or Advanced Server, and the backup can go to your storage bucket of choice. So because you're using Cloud Native Postgres, you have the freedom to continue using Cloud Native Postgres. Those were standard backups that I just showed via Barman Cloud. So those are in your storage bucket. You could restore those to a VM if you wanted to, or you could deploy those to another Kubernetes cluster if you wanted to. All right, so next steps, I'm just going to highlight here. If you go to enterprisedb.com, go to resources, docs, Cloud Native Postgres, all of the features that we talked about are well detailed there. And there's also a demo that you can do, an interactive demo using Katacoda. So, hey, I want to test Cloud Native Postgres real quick. You don't need to deploy a local Kubernetes cluster. If you don't want to, you can run through that on our website. All right, thank you, everyone. Go to questions now.
All right, thank you, Adam. So we have a few questions over here. One of them is, can you recap how the storage is managed when a new instance is added to the cluster and what happens when a VM fails? So they're interested to understand how a large instance is brought up in Kubernetes.
Yes, so recap how the storage is managed when a new instance is created. So the storage is dynamically created, and the larger the database, so you have all your standard PVC options, all the same volume options that you would have in other contexts or for other parts of Kubernetes. So you initialize a new cluster. The way we do it right now with dynamic provisioning, so you already have a 1 terabyte database running, then your second instance, as of today, is going to take a PG base backup of that first cluster. So if it's a terabyte, that's going to take as long as a PG base backup takes. The option that we're adding to the operator is if you have a full backup, when you add that second pod, or you're initializing a cluster, you have instances :3, instead of taking a PG base backup, that we could go to a full backup that's already been taken. Now that'll take as long as it takes to pull down the backup, but it's less work and it's going to be faster in most situations to PG-based backup. So it's the storage is dynamically provisioned. The operator is really designed to be storage agnostic. So all of the storage options that you have are, available to you. And then what we're trying to do with the operator is for large databases, having churn in your cluster, adding new instances happens pretty fast. If it's, 100 gigabyte or less, when you get into terabytes, then reconciling the cluster is going to take a little bit longer, but we'll try to cut that down with the PG-based backup option. Hopefully that answered the question. If not, feel free to drop that into the chat.
Cool. Thanks, Adam. Okay, another one. Can a Postgres cluster stretch across different Kubernetes clusters?
Yes. So the documentation page that I referenced, if you go to resources, docs, and Cloud Native Postgres, search on a feature called replica cluster. So this is pretty slick. So you'll have a Kubernetes cluster on one side, and then another Kubernetes cluster. So say data center A, data center B, could be within the same data center, but this helps support multi-region workloads. You have 3 instances on one side. Your primary is going to replicate to an inferred primary on the other side. So this is using that same bootstrap framework. So instead of the initdb option under the bootstrap framework, you're going to actually be pointing to an external cluster. And that, if you're using B, the external cluster is going to be A, and that's going to be getting the live stream of streaming replication data. So once a transaction is committed on site A, it's going to automatically stream those changes to site B. You can do that. If you want to do wall archiving as well, there's another option where you could just fetch the wall archives. And then there's a third scenario where you're doing streaming. Maybe there's a bad firewall rule or something that goes into place. That streaming replication connection breaks, and then the site B is going to try to start fetching the wall files, because a common scenario that we're seeing is, we're pushing the backups to an object store. It's in that object store also has its own replications. So maybe behind the scenes, that object store is shipping the backups and the wall files to the same region as, the Kubernetes cluster B is in. But replica clusters is the keyword that you're going to want to use on the documentation to get more details.
Great, thank you. Okay, so there's one question here referring to a slide that was in the webinar. So if there's a service that connects to 3 Cloud Native Postgres databases, so 1 primary and 2 replicas, yep, what happens if the service that connects to them goes down?
If the service, so this is going to use Kubernetes reconcile loops. So the service goes down, then Kubernetes is going to detect that with its reconcile loops and automatically create a new service.
Cool.
Yeah.
Okay. One last question. Is connection pooling available with Cloud Native Postgres?
So, yeah, so our connection pooling feature is going to be part of the deployment. So we expect that to be late October, early November, and that'll be via PG Bouncer. So PG Bouncer will be a separate image. It'll be part of your deployment. You could add it to your deployment if you wanted to, and it's going to be managed in a declarative way, just like the other features, or you can not run with it. So it'll be just another part of the deployment later this month, early November.
Great, awesome. Well, Adam, thank you very much. And thank you everyone else for attending the webinar. As I mentioned at the beginning, we'll be sharing the recording as well as the slides with you as soon as possible via email. So thanks again and have a great rest of your day.
Thank you. Bye.